Okay, the next thing we are going to do in this experiment, we are going to remove the bar magnet. And then after removing the bar magnet, we are going to observe what is going to happen to the iron and what is going to happen to steel. So that one takes us to the next diagram here. Remember this diagram here, we are saying before removing the magnet, this is what will happen. What about when you remove the magnet? Now when you remove the magnet, here we are talking about after removing the magnet. Immediately you remove the magnet so that steel remains alone and the iron remains alone. What happens? You'll realize that the iron filings which were attached, which were attracted to the steel will remain there. They will remain attracted. But the iron filings which were on the side of the iron, all of them will fall away. What does that mean? It means iron loses magnetism very fast. It is easily demagnetized, while steel does not lose its magnetism anyhow. So for that matter, it keeps its magnetism for a long time. That's why you have the iron filings are still here, but here they are not there at all. So what do we conclude? We conclude by saying iron is easily magnetized and demagnetized, while steel is not easy to magnetize, which means it is difficult to magnetize. But after magnetizing, it will keep its magnetism for a long time. Now, when somebody tells you to describe an experiment, now I'm teaching you the examination techniques. You need to draw a diagram, and your diagram must be a workable diagram. Now, look at the diagram. That's what we mean by a workable diagram. First of all, the diagrams are clear. Secondly, they are labeled. So if you draw your diagram and it is not labeled, then it is not workable. Supposing you had drawn this and you did not label it as iron, it will be very hard for the examiner to know what you are meaning. So you must have a workable diagram. After the diagram, you don't end there. The next thing is you describe the experiment. You see, you say iron and steel strips of the same dimensions are brought near the lower ends of a bar magnet. So you bring the iron and steel towards the lower ends of the magnet. Then the next thing, what happens? The iron filings are now brought. Now you bring this one. After connecting the iron and steel to the magnet, the next thing is you bring the iron filings. That's why we are saying the iron filings are brought close to the lower ends of iron and steel, and then the magnet removed. So after connecting this and that to the magnet, the next thing you bring the iron filings towards the iron and what? Steel. Then after that, you remove the magnet. Now when you remove the magnet, you end up with what? The next what? The next diagram, this one. So iron and steel strips of the same dimensions are brought near the lower ends of a magnet. Iron filings and then they are then brought close to the lower ends of the iron and steel, and then after that the magnet is removed. Now after removing, what do you observe? The examiner is interested in knowing the observation. The first observation will be iron and steel are both attracted to the magnet, and then after getting attracted to the magnet, they become magnetized. And after being magnetized, remember, after you have removed the iron filings, remember, the iron and steel are both attracted to the magnet. After they are being attracted, the next thing, they become magnets. They are magnetized. And once they get magnetized, what do? They now attract the iron filings. Very important observation. Then, another good observation is, you look at the number of iron filings which get attracted. So you comment about it. More iron filings are attracted to the iron than steel. What does that mean? It means the iron filings will be attracted both to steel and iron, but more will be on the iron and few will be on the side of steel. Then now you give us the final comment. When the magnet is now removed, what happens? According to this diagram, when the magnet is removed, what happens? So you come and comment. You say, on removing the magnet, what happens? All the iron filings which were on the side of the iron, they do what? they fall off, they fall away. While the iron filings which were on the side of steel, they don't fall away. They don't fall at all. Now, these are the observations. So from the observations, you should now be able to conclude. Whenever you are doing an experiment, make sure you conclude. You cannot conclude before you tell us what you see, the observation. Now, look at our conclusion. Our conclusion is iron gains magnetism faster than steel. I think that was very clear in the first diagram. Then the second observation, the second conclusion is iron loses magnetism very fast, while steel keeps its magnetism for a long time. That one, we got it from the second diagram. So, how does the examiner award the marks? You will be awarded one, first of all, through the diagrams. The workable diagram, you see? The diagram is workable. See? So you get your marks. Then the second area where you are going to get marks will be on description. When you are describing, you see? Iron and steel strips of the same dimensions, you see? So you get something. When I tick and I put a cross, does not mean that you are wrong. It means I've given you a half a mark. It is not a full mark. It is a half what? A mark like this. So the major area is same dimensions. Brought, then the next statement says, are brought near the lower ends of the magnet. Possibly the position of the magnet also matters, the lower end of the magnet. So you get something there. Iron filings are brought close to the lower ends of the iron and steel. There you also get something. Iron filings are brought close to the lower ends of iron and what? Steel. You get something. Then the next one is the magnet being removed. You also get something there. Are you seeing? So these are the key areas which you have to look at. Then under observations, you also will be awarded the marks. The iron filings being attracted, you get something. Becoming magnetized, you get something. You see? And then attracting the iron filings, you also get something. Then more iron filings, commenting by number, the number of iron filings, more are attracted on the iron than steel. You get something. Then after removing the magnet, what happens? You realize that all the iron filings on the side of the iron, they do what? They fall away. You get something. Then what happens to the ones on steel? They don't fall away. You also get something. Then you come and conclude. They may give you a half for the first conclusion and a half for the next conclusion. So at the end of the day, you have your marks. You see, right from the diagram, you come to describing. Drawing a diagram and naming the parts of the diagram is not enough. You must talk about the diagram. So after the diagram, say something about the diagram. Then you come for observation. Then after observation, you come and what? Conclude. So I want you to critically analyze. Look at this diagram. See? The diagram must be workable. Then after that, you come and talk about the diagram. Then after that, you come and talk about the observation. What do you see? Then finally, you come and what? Conclude. So this is how you describe an experiment. All the experiments, and normally they carry more marks. They carry more marks because they know you are going to talk much. So you should have your heading there. You come for the diagram, workable diagram. Then you talk about the diagram. Then you come for observations. And then you go for conclusions. And that marks the end of your description. So let us have a commercial break, then we continue.